Let us consider the article that show that A plus R plus T is equal to 1. Show that A plus R plus T is equal to 1. What do we understand by A? A is nothing but coefficient of absorption. What is R? R is the coefficient of reflection. And what do we understand by T? T is nothing but coefficient of transmission. Sometimes question asked in HSC board for 2 marks in this way, that how or show that the sum of coefficient of absorption, comma reflection, comma transmission is a unity. Or sometimes in this way, show that A plus R plus T is equal to 1. So to obtain how A plus R plus T is equal to 1, let us consider a simple diagram. Let us consider a simple diagram. Let us consider a body. Okay. To understand the concept of A plus R plus T is equal to 1, let us consider there is a body on which some amount of heat is incident, that is called as incident heat. Some amount of heat is incident on a body. Whenever heat is incident on a body, at that time, some part of heat absorbed by the body, some part of heat reflected by the body, and some part of heat transmitted through the body. What we have see here, that what happens here, that whenever heat is incident on a body, it is incident on a body. Yes. What happens whenever heat is incident on a body? Some part of heat is absorbed by the body. Okay. Some part of heat is absorbed by the body, represented by the factor HA, comma. Again, what happens? Some part of heat is reflected by the body. Some part of heat is reflected by the body. It is represented by the factor HR. Again, what happens? And some part of heat is, yes, some part of heat is transmitted through the body. Some part of heat is transmitted through the body, and that is represented by the factor HT. Mathematically, above this explanation, we can write mathematically, yes, it can be written as that is heat H, that is nothing but the amount of heat, that is nothing but the total amount of heat incident on a body. What happens? Some part of heat is absorbed, plus again what happens? Some part of heat is reflected. Again what happens? Some part of heat is transmitted. That is H is equal to HA plus HR plus HT. Dividing both sides by H. Dividing both sides by H. What happens? We get H upon H is equal to HA upon H plus HR upon H plus HT upon H. Then what happens? This HH, this factor gets cancelled. What remains here? 1. What is this? It is the ratio. This is the ratio of amount of heat absorbed by the body. From where? to the total amount of heat incident upon it, plus what is this? This is the amount of heat, this is the ratio of amount of heat reflected by the body to the total amount of heat incident upon it. Again, what is this? This is the ratio of amount of heat transmitted through the body to the total amount of heat incident upon it, denoted by the factor A, denoted by the factor R, and this is denoted by the factor T. That's why we can prove that the sum of coefficient of absorption, reflection and transmission is unity, or A plus R plus T is equal to 1. Hence the proof. Watch it. Sometimes question asked in this way, that define the terms, define the terms. Number 1, coefficient of absorption. Define the terms. The first one is coefficient of absorption. So what do you understand by coefficient of absorption? It is the ratio, it is the ratio of amount of heat absorbed by the body. Okay, it is the ratio of amount of heat absorbed by the body to the total amount of heat, to the total amount of heat incident upon it. Yes, what we get the idea here, that the body is absorbing the heat from where? How much heat is incident upon it? It means that whenever heat is incident on a body, some part of heat is absorbed by the body. It is denoted by the factor A, mathematically written as HA upon H. You can represent instead of H, QA upon Q. Q be the amount of heat. So what we get the idea from this definition? We get the idea that whenever heat is incident on a body, some amount of heat is absorbed by the body. The ratio is called as coefficient of absorption. The second point, that what do we understand by the term coefficient of reflection? What do we understand by the term coefficient of reflection of the same type? The same things, that it is the ratio of amount of heat. It is the ratio of amount of heat reflected by the body. Amount of heat reflected by the body to the total amount of heat, to the total amount of heat incident upon it. Yes, what we get the idea from this sentence? Whenever heat is incident on a body, some amount of heat is reflected by the body. Okay, and it is denoted by the factor R, mathematically written as R is equal to HR upon H. What do we understand by H? H is the total amount of heat incident on a body. Out of that, how much? Some amount of heat is reflected by the body. The ratio is called as coefficient of reflection. Again, sometimes it is asked, that is coefficient of, what do you understand by coefficient of transmission. What do you understand by the term coefficient of transmission? Same. Coefficient of transmission, it is the ratio of, it is the ratio of amount of heat, it is the ratio of amount of heat transmitted by the body. It is the ratio of amount of heat transmitted by the body to the total amount of heat, to the total amount of heat incident upon it. Yes. Again, what we get the idea from this statement, that whenever heat is incident on a body, what happens? Some amount of heat is transmitted by the body, and it is denoted. It is denoted by the factor small t, mathematical written as T is equal to Ht upon H. What do we understand by Ht? Ht be the amount of heat transmitted by the body. And what is H? H is the total amount of heat incident on a body. So from these three definitions, what we got the general idea? We got the general idea that this is the body, okay, and this is the H, that is called as total amount of heat. What happens whenever heat is incident on a body? What happens? Some amount of heat is absorbed by the body, and some amount of heat is reflected by the body, and some amount of heat is transmitted through the body. On this concept, we define coefficient of absorption, coefficient of reflection, and coefficient of transmission. Watch it carefully. Now let us consider the another important point, that what do we understand by the term emissive power? What do you understand by the term emissive power? Emissive power, it is the ratio of, emissive power is defined as, it is the ratio of radiant heat energy. It is the ratio of radiant heat energy per unit area per unit time. What do we understand by emissive power? Emissive power is the ratio of, it is the ratio of amount of radiant heat energy per unit area per unit time. It is denoted by the factor emissive power, that is capital E, okay, written as that is E is equal to, what do we understand by the ratio? That is nothing but the ratio, okay, ratio of radiant heat energy, it is denoted by the factor Q, per unit area A, per unit time T. So E is equal to Q by AT. What do we understand by emissive power? Emissive power is the ratio of, it is the ratio of radiant heat energy per unit area per unit time, denoted by the factor E, having dimensions. Its dimensions are m raised to 1, L raised to 0, T raised to -3. Units, its units are, energy is measured in joule, area is measured in meter square, time is measured in second. So what do we understand by emissive power? Emissive power is the ratio of amount of radiant heat energy per unit area per unit time, denoted by the factor E, mathematically can be written as E is equal to Q by AT. It has the dimensions m raised to 1, L raised to 0, T raised to minus 3, and it is measured in joule per meter square second. Now, what do we understand by the term coefficient of emission? What do we understand by the term coefficient of emission? Okay, coefficient of emission, it is the ratio of emissive power. It is the ratio of emissive power at a particular temperature. Emissive power at a particular temperature to the emissive power of a perfectly black body. Just try to get the meaning that what do we understand by coefficient of emission? It is the ratio of emissive power of a body at a particular temperature, that is nothing but the ordinary body. Emissive power of an ordinary body, emissive power denoted by the factor E, okay, to emissive power of a perfectly black body, that is EB. It is denoted by the factor E. So what we can write, E is equal to E by EB. What is this E? EB, the emissive power of a ordinary body, and EB, it is the emissive power of a perfectly black body. It is denoted by the factor E, so we can write E is equal to E by EB. See here. Let us consider another important point that explain what do we understand by perfectly black body. Explain perfectly black body. Now first we will see that what do we understand by perfectly black body. When a body absorbs all radiant heat energy, incident upon it. What do you understand by perfectly black body? Whatever heat is incident on a body, and if the body absorbs all heat, then it is called as yes, perfectly black body. Yes, what do we understand by perfectly black body? Whenever radiant heat incident on a body, and if the body absorbs all amount of heat, then it is called as perfectly black body. Let us consider the simple diagram of a perfectly black body. What we are observing that a black body consists of a hollow double walled sphere. A hollow double walled sphere, hollow, that is completely empty. Okay, double walled sphere, it is a hollow double walled sphere having a small conical projection, having a small conical projection. This is nothing but a small conical projection at the center. Where it is situated? It is situated at the center. What do we understand by first? A perfectly black body. Whenever heat is incident or whatever radiant heat is incident on a body, and if the body absorbs all amount of heat energy, then it is called as perfectly black body. What do we understand by a black body? A black body from the diagram consists of a hollow double-walled sphere having a small conical projection at the center. Okay, this is the radiant heat energy. Radiant heat energy. What we are observing in the diagram? We are observing in the diagram that whenever a radiant heat energy, yes, enters into the body. Whenever a radiant heat energy enters into the body, then what happens? It first incident on a conical projection. It first incident on a conical projection. We are observing here that the radiant heat energy entering in the body and going to incident on a conical projection. What happens? Then the heat undergoes multiple reflections and refractions. What happens? As soon as the radiant heat energy incident on a conical projection, what happens? The radiant heat energy, it undergoes multiple reflections and refractions. During each reflection and refraction, 98% of heat is absorbed by the body. So it is called as, that's why it is called as perfectly black body. That's why it is called as perfectly black body. Generally, for example, lamp black. What is its example? Its example is lamp black. It is said that coefficient of absorption that is represented by the factor A of a black body is 1. That is nothing but the maxima. So what do we understand here? Whenever radiant heat energy enters into the black body, falls on the conical projection, what happens? It undergoes multiple reflections and refractions. During each reflection and refraction, 98% of heat is absorbed by the body. That's why it is called as perfectly black body. The coefficient of absorption of a perfectly black body is 1, and generally what is the example? Lamp black is used as a perfectly black body. Watch it.